It's finally time to take a look at Unity's root motion system. This means we can use animations, just like this one, that have rotation or displacement baked right into them. For our example, I've downloaded a running animation, the one we just saw, but with root motion, and also a walking animation with root motion. For idle, I don't need a different flavor because there isn't really any displacement happening during that animation. Now, on the left here, I have set up our current player, and on the right, this is what we're going to try and accomplish in the following few minutes. So, on the right, we have root motion, and on the left, we do not. Let's compare and contrast. I will select the player, and as we know, if I check is walking, we start walking in place. So I'm not pressing W, I'm not calling my displacement code that we've written before. If I select this second game object and I check is walking, well, we get this really nice walking animation and the displacement that goes along with it. So we can see the position actually changing here, while it is not changing for the first player object. Let's perform one other test. So here I can go from walking into running, and that looks great. Let's take a look at how I actually accomplished this so you can do it yourself. Now, at my running root motion animation and my walking root motion animation, I did the same steps as we did with the previous animations. So I take rig, humanoid, copy from other avatar, and I select the player avatar. Nothing new here. I also create a copy of my previous player animation controller, sorry. And they seem pretty similar. The difference is that this one, the second one, is for using walking root motion animation and here running root motion animation, which means that my player root motion game object here is using that second controller, while this one is using the first controller. So it's using this animator, which does not use the root motion variant animations. Now, just doing this is not enough, however. I also had to check a few other boxes. So I'm going to go here in animation for my running root motion, and you can see that I've checked this loop pose, bake into pose for the running and also the walking. And that's not all. I also checked here, apply root motion on the animator. However, I did not check that here for the first player object. Let's take a look at the significance of some of those checkboxes. So, the first one, apply root motion. Let's say that I do not apply root motion. And I'm going to turn my walking on. Well, I don't really get that displacement. I'm not applying root motion. In other words, I'm not applying any of the displacement and rotation transformations baked into the animation itself onto my game object's transform, which is why it stays in place and we don't see any values here changing. Now I'm going to put that back on and let's look at it again. And we can see just with the idle, there's actually some position and rotation change. Let's look at it in the scene view and take a look at the origin here and the three axes. We can definitely see some rotation and transformation in terms of position happening. Now, when I said that the idle animation doesn't have any displacement nor rotation, I actually lied. It has a little bit, not that much, but still enough to be significant. Because, for example, let's say that at this moment, not that moment, let's try another one. No, come on. All right, here, perfect. Let's see, we have 13 degrees of rotation around the y-axis. Now let's say that at this point in time, I start, moving my character forward by pressing W, or I check is walking. Let's actually see what happens. It's not going straight from its initial position. It's following, well, its z-axis, which has this direction. And you can see it's definitely not parallel to these lines here. So that's an issue. I don't want it to be like this. For example, I never know which direction I'll be moving towards if I press W with this kind of behavior. Now, how do I stop that? I just have to go into the idle animation and check a few boxes. So here, root transform rotation bake into pose. If I check this, that means I won't apply the transformation in the object to the transform of the game object. So let's look at this. Again, I'm not applying any of the rotations in this animation to this game object's transform. And we still get this position change, but however, my Y is not changing here in terms of the rotation angle. That's great. So if we can do that with rotation, I can do the same thing with XZ transforms and also with Y. So I don't think we had anything happening on Y here, if I recall, but I can just check it to be safe. And there we go. We still have our animation, but our orientation isn't changing. So if I start walking, I'm following this straight line. Great. Now, as you might expect, I had to do this also for my running and walking animation. So let's take a look at the walking one. I have this loop pose and all these other ones. Well, actually, just one more bake into pose, the rotation. So I didn't do anything about the Y transform nor the XZ transform. Let's say that I actually check this. Let's see what happens. So I'm going to go to is walking. Yikes. So there is some Y transformation happening, but not X nor Z. So that's not what we want. In this case, for the walking, we do want to apply the transformations in the animation to the game object's transform. So I don't check this. I could check it for Y, however. Let's try that. Cool. So that's not bad at all. What else? Let me go back into my walking animation. So for Y, for stuff like idles, walking and running, you can have this checked. But once you have animations where characters jump and such, it becomes a bit more complicated, and you probably should not have this checked. What is this loop pose? So I'm just going to uncheck that and restart my animation. So there's nothing really visible here. I believe that I actually checked this accidentally. And I didn't even notice because, as you just saw, there's nothing really noticeable in this specific case. So just to save time, I won't take any more time to explain what this loop pose is, but just know that when you have this green light here, you can check it and you shouldn't have any problems. If you don't check it, I can't remember what the consequences are exactly in the long term, so might as well just have it on for now. So I have something similar as well for my running root motion animation. So let's take a look at that final result one more time. There we go. Following the straight line. And once again, let's just show the difference. Let's say I do not check any of these things. Oops. I will keep the idle one checked, however. So, okay, let's start walking. That's pretty drunk. Start running. And yeah, that's even worse. So I just discovered a small problem here. Let's say I spam this is walking. Okay, as you can see now, my character has actually moved down into the plane. We see that the character's Y has gone down. So I actually want to make sure that in my running and walking root motion, that I have this root transform position Y bake into pose checked. All right, let's try that again. And we can see that our Y is fine. Take a look at this behavior. Both characters are looking at the mouse. Now, what I've done is not give them different scripts. They both have the same animation test script, but I've changed that script. So we'll go back soon in the code and see how I did that. But also, I removed any code that translated the position of the character. So if I press W now, we expect this left character to walk in place, but this one to move using its root motion. And the same thing kind of goes for shift, for running. Now, as you'll notice, once the character arrives at the mouse, it's kind of flipping out a bit. So there are ways to fix that in code, but just for time, I will skip that verification and not fix this issue. So it looks a bit weird, but oh well. Back to our code, we can see that I've cleaned this part up a bit. I've removed the walk speed and run speed, for example, since speeds are now baked into our animations using the root motion. Awake becomes a one-liner, so I can write it using expression body syntax, just for fun. I've removed the move forward function for obvious reasons, since now our displacement is not done programmatically, but through the animation itself. And now this is something that I failed to notice before, but I should have added, excuse me, this line of code and this line of code into this action. Because let's say that we press W to walk, so we start moving, and then I hold down shift to start running, and I let go of W but not shift. So previously, I was just saying, okay, so walking param hash set it to false and is moving is false. But I wasn't saying the run animation to false and is running to false, which meant that I stopped moving, but the run animation did not stop. So it was keep going on in place, and that's obviously not what we want. So that's the fix here. And what's really new is this handle rotation that's getting called each frame. And Ryder's actually telling me that this is an expensive method invocation. This is an expensive function call, since I'm calling it every single frame. Now, this doesn't mean to completely avoid calling this function. It's just telling me to be aware of this function and its price. So I have to stop and think for a second. Is this going to be an issue in my game? Now, I know that for my game, I won't have 100 different players or 1,000 different players or tens of thousands of players that will rotate depending on my mouse. Actually, having even 2 players, like in the example, is quite far-fetched. So, ideally, my game will only have one game object that will call such code. So I don't have to worry about having, again, tens of thousands of game objects with this script running handle rotation 60 times a second, for example. And the code here actually isn't all that bad. Now, there are ways to make it a bit more optimal, but again, for time, I won't go into that. And what's happening here is just some basic trigonometry. So let's talk about it real quickly. But actually, I just noticed that this is not written correctly. It should have capital H. So this is actually Pascal case. Before it was camel case, functions should be with Pascal case in C#. All right, so that's fixed. Great. Now let's take a look at this. What is this first line of code? Well, I'm transforming my world space position into a screen space position. So I'm just going from one space to another space. How is that done? Well, some basic linear algebra transforms we don't need to really understand. What we do need to know is that screen space is basically, well, image space for those of you who've taken graphics course. So it's dependent on your actual screen resolution. So it's like this 2D space defined by your pixel resolution. Now, why do I need this? Why do I want to know where my character is on my screen? Let's say my character's origin is here. Well, what point on my screen is that? Well, I would have an X and Y value. But what's the point of this? It's because I want to use the mouse position. And the mouse position, well, that's obviously in pixel coordinates. That's in screen space. And I want to do this mouse position minus screen space position operation to get a direction. So both of these vectors should be in the same space for this to make sense. So I take my player's position in world space and I get it in screen space, and then I do this mouse position in screen space minus this character position in screen space to get a direction. Now I use this trig function, so a_tan2. Now I won't plot it out or draw you a nice triangle to figure out what the trigonometry is here, but you can do that on your own time. So this gives me something in radians, and I just need to bring that to degrees for the following function call here. So now I just multiply this by matf.rad to deg, so rad to degrees, and then I can finally affect my rotation. So I update the rotation of the game object by calling this function. So I give it an angle and an axis. Now, what is this axis? You can just play around with it. Play around with different values like dot down, up, left, right, forward, and back to see what its impact is. I don't want to take more time to go into in great detail about how this function works internally. And if you don't want to take the time to understand all the math in this function, obviously you don't have to, because this isn't the point of lab 1. So feel free to copy and paste this code. If you have some time, well, try and understand it, which would be great, obviously. But if you don't, we completely understand.